Hello, in this video we will talk about the trigonometric form of the complex number. In order to define it, we have to define some terms. So first of all, we will define the modulus. So modulus of a complex number z is just the distance of its image point from the origin. Okay? It means suppose you have a complex number, for example, 5 plus 2 iota. Suppose this is your complex number. If I draw this complex number on the origin, so if I draw this complex number on the graph, I have 5 comma 2, so I will write 5 comma 2. So 5 is along x-axis, on the positive side because x is positive. So 1, 2, 3, 4, 5. So this is along x-axis 5, and along y-axis I have 2. Since it is positive, so I will go up. So I'll write 1 and 2. Okay, so this is 5 and this is 2. They are meeting here, so this is the point. Okay, so we can draw an arrow from the origin to this point z. Okay, so this is the point z. So what's the definition of modulus? Modulus says the modulus of a complex number is the distance of the point from the origin. So this is the point. Its distance from the origin is this whole distance. It's the magnitude of this vector actually. So how can I find the magnitude of this vector? In this case, because this length is 5 and this length is 2, we know, because this is 5 and this is 2. So we can easily find, we can use Pythagoras theorem to find this distance, because Pythagoras theorem says the square of this distance is equal to the sum of square of this and the square of this. What does that mean? This means this length, which I don't know, this length is, the square of this length is equal to, if this length is x, then the square of this length is equal to the sum of two squares. The first square is this one, the second square is this one. This is what Pythagoras theorem says. From here, I can find the value of x by taking square root on both sides because I need the value of x. So in this way, I can easily find the value of x. Okay, so this is the distance. So what's the modulus? Modulus is the distance from the origin. So if you have any complex number, how will you find the distance? I will give you the general formula. Here is the general formula. So general formula says if z is a complex number whose real coordinate is a and whose complex coordinate is b, or you can write it in this way, a comma b, then we can first draw this complex number on the graph. Suppose this is your a and this is your b. So this is point a plus b iota. This is point b. If I draw a vector joining this point and the origin, so then I can easily find the modulus. Okay, so how can I find the modulus? First of all, I will draw this triangle. In this triangle, this distance is a and this distance is b. This perpendicular distance is b. I have to find this distance. Suppose this distance is x. Okay, in this triangle, I can easily use the Pythagoras theorem. Pythagoras theorem says the square of this is equal to the square of this length, which I don't know, I call it x, it is equal to the square of this plus square of this. A square plus b square. But I need x, I don't need x square, but here I have x square. What will I do? I will apply square root on both sides. Okay, once I apply square root on both sides, this square and square root will get cancelled, but you cannot cancel this square and this square root because here you have plus. It is equal to a square plus b square square root so x is equal to this whole thing. Okay, so this x is actually the modulus. This x is the modulus of a complex number. You can call it, it has some notation. We will not call it x, it has special notation. This modulus is denoted by, it is denoted by z mod. Okay, so this is the way how to denote, how we denote any complex number z. Okay, so this is the notation. So we write, if z is equal to a plus b iota, then the modulus of z will be a square plus b square square root. So this is, we call the modulus. I mean, just take the square of this, just take the square of this and apply the square root. Just we did. So I have shown you this distance can be written as a square of sum of the square. In generally, if you want to find the modulus of any complex number, what you have to do, you have to find the square of the real part plus the square of the real part and apply square root. Here is an example. Modulus of 3 minus 2 iota. Here is the solution. If you want to find the modulus of 3 minus 2 iota, what will you do? Suppose this is z, so its modulus is denoted by this. You have to write this formula. This formula says the square of the real part. Here the real part is 3, so I will write the square of 3 plus square of imaginary part. Here the imaginary part is negative 2, so I will write the square of negative 2. Okay, so square of 3 is equal to 9 plus square of negative number is always positive number, so square of 2 is 4. So I can write it is equal to square root of 13. So this is the modulus. So this is the way how you find the modulus of a complex number. Once we have defined the modulus, then we will define the argument. What is an argument of a complex number? Okay, so the argument of a complex number, suppose the complex number is a plus b iota, is the angle between the positive part of the x-axis and the semilinear line OP. So we suppose we have again this graph, a plus b iota is our complex number. So what it says, the argument is the angle between the positive part of the x-axis. You know, this is x-axis, it's negative part, and this is positive part. So he is saying we have to find the angle from the positive part of the x-axis to the semilinear line OP. Semilinear line OP, O is this and P is the point where the arrow ends. So we have to find the angle between the x-axis to this semilinear line. We have to find the angle. So this angle is called the argument. Okay, so this angle which starts from the x-axis which goes towards the line OP, it is called the argument. So it is true if and only if the complex number is not equal to 0. What if the complex number stays here on the origin? It is only 0. I mean, that means then you will have no such vector, just like you have this one. If the complex number is 0, so everything is in the origins and then there is no argument. So then we can have no argument. Then we say that argument is undefined. So we have notation for this argument. Here is the notation for that. Notation is arg of z. When I say arg of z, that means I'm talking about the argument of z. Usually we denote it argument by this, or we denote it by theta. Okay. Now the question is how to find this argument. Okay, we have two things associated with every complex number. The first thing is the modulus, which is the distance of the complex number from the origin. And the second thing is find the argument of the complex number. Okay, we know how to find the distance of the complex number from the origin, but we don't know how to find this angle. I'll give you the formula for this angle. The formula to find the angle is very easy. We know from here tangent theta, a trigonometric ratio which is tangent theta. If I apply the trigonometric ratio tangent theta on this triangle, we know the tangent theta is equal to the height over base. Height is b and base is a, so it is equal to b by a. Okay, so the tangent theta is equal to b by a. This is the formula. In order to find theta, if you want to find theta, then you can shift this tan to the right hand side. If you want to shift tan to the right hand side and theta will stay here, then tan will go to the right hand side, but it will become inverse. So you have theta equals tan inverse of b by a. So if you plug these values in the calculator, you will get the answer. So let's do an example. In this example, we have to find the modulus and the argument. For the complex number, z is equal to 3 minus 4 iota. Okay, here is the solution. In order to find the in order to find the modulus, I will just write the square of this. First of all, I will write the square root, then square of this, plus square of minus 4, which is just the formula which we have defined few minutes ago. 9 plus 16, because the square of negative number is positive. 9 plus square root 16 is equal to 25. I'll write here 25 square root. Since the square root of 25 is just 5, so the modulus of z is equal to 5. Now we will find the argument of z. Okay, so the argument of z, by the formula, we have argument of z, which is theta, equals to tangent inverse of b by a. Okay, because this is the formula, tangent inverse of b by a. This is the argument. You know, theta and argument are the same. I told you, you can denote the argument by arg of z or by theta. Okay, so theta equals tan inverse of b over a. So in this example, this is your a and negative 4 is your b. Okay, you have to first separate what is a and what is b. You can write it 3 comma minus 4. This is your a and this is your b. So b is negative 4 and a is 3. So you will write tangent inverse of negative 4 by 3. So if I calculate this value from the calculator, it will give me negative 53.13 degrees. Okay, since the period of tangent theta is 180 degree or pi radian, so since the period of tangent theta is 180 degrees, so that means I can add or subtract 180 degrees from this angle. Either I can add 180 or I can subtract. Similarly, I can add 2 times 180 or I can subtract. Okay, because this is the period is the number which you can add or subtract, your answer will remains the same. I mean, if you add or subtract this period, that means your answer will be correct. That doesn't mean the answer is same. That means your answer will be correct. For example, if I add 180 degree in this angle, so my argument will be negative 53.13 degrees plus 180 degree. Okay, so if I solve it, I will have 126 degrees, 126.869 degrees. Okay, so this one is correct answer or this one is correct answer. We will check. If I make the diagram for this complex number, so if I make this angle which is negative 53, so from here I have to draw this angle from here. Okay, whenever you want to draw an angle, you will start from the positive x-axis. You can go up or you can go this way. Okay, if you go this way, your angle is positive. If you go this way, your angle is negative. Okay, and you know, from here, if I go at this point, I will cover 90 degrees. And if I go from here to here, I will cover 180 degrees. Similarly, if I go from here to here, I will cover minus 90 degrees. And similarly, from here to here, I will cover minus 180 degrees. So this is the way how we cover an angle. So the first possibility is negative 53.13. Since from here to here I have 90 degrees, so I have to stay here somewhere because my angle is 53. So I have to stop sometime, before the negative 90 degrees, right? That means I am in the fourth quadrant. This is the first quadrant. This is the second quadrant. This is the third quadrant. And this is the fourth quadrant. Okay, now look, what was my complex number? My complex number was 3 minus 4 iota. 3 minus 4 iota means you have 3 comma negative 4. Okay, 3 is positive, for example 1 2 3, and this minus 4 is negative. That means along y-axis I have to go down. If I go down, I have 1 2 3 4. So this is my complex number right over here. So that means this angle is correct. Okay, that means this angle negative 53 point something completely determines my point. Otherwise, if I take this angle, I have found it correctly, because whenever you find an angle through the tan inverse of the function, then you can always add or subtract. You can always add or subtract 180 degrees because the period of tan is 180 degrees. So after the addition of 180 degrees, I got 126. So if I draw this angle on this diagram, I will go from here to here. I got 90 degrees, but I have to go to 126. So that means here I have some line. But this line cannot determine my point, because my point was 3 comma negative 4. So my point cannot be here, because in order to be here, it should be negative 3 on this side and positive 4 on this side. But my point is not negative 3 positive 4. My point is 3 negative 4. So that means this angle is correct. This angle does not determine my point, but this angle completely determines my point. So in this case, our argument is this one, not this one. Okay, in some cases, our argument can be changed. Our argument can be something else, but we have to check in which quadrant our point is lying. According to the quadrant, we can add or subtract 180 degrees because we can always obtain the angle from tangent theta, right? Now we do another example. We take another number which is similar to this one but not this one. Suppose we take negative 3 comma 4. I mean z is equal to negative 3 plus 4 iota. Then what will be the argument? Okay, then the argument of z will be tangent inverse of b by a. You know, this is my a, this is my b. So I'll write b by a. Since my b is 4, so tangent inverse of 4 by negative 3. So I'll write tangent. So if I do the calculation from the calculator, I will again get 53 point, I don't know, 13 or 36. Yeah, it's 13. But this angle is negative. Now if I again draw on the complex plane, what will I get? If I draw this negative 53, so that means I'm going to draw the angle to the negative side because this is the positive side. Drawing angle from here to here is positive side, but drawing angle from here to here is negative side. But our angle is negative, so I will go from here to here. From here to here, I have negative 90 degree, but I have to go less than negative 90. So I have to go from here to here. Before 90. So I will stop somewhere here. Okay. So, but my number is negative 3 plus 4. Negative 3 means along x-axis. This is the x-axis, and this is negative x-axis, and this is positive x-axis. So negative 3 will be 1, 2, 3 here somewhere. Okay. And positive 4 is along y-axis above the x-axis, right? Otherwise, it will be negative. So here is positive 4. So here is my point. Okay, but this angle does not determine my point because my point is not here. My point is here in the second quadrant. So that means this angle is not working. This is not working. So what I have to do, I have to add 180 degrees because 180 degree is the period of tan pi. So add 180 degrees in the argument. So argument of z is equal to negative 53.13 degrees plus 180 degrees. If I add it, I will get 126.869 degrees. So this is the correct way because if I draw this angle from here to here, because this is positive, and the positive angles can be drawn from here to here. From here to here till this line I have 90 degrees, but I have to go more than 90 degrees. So I will go beyond this line. So that means this will be my angle. So now this angle can take me to this point. So that means I am correct. I am done. So this way you determine what is your argument. Your argument is always depends upon the quadrant where the point is lying. If you find the argument and that on that argument your point is not found and your point is somewhere else, you have to add or subtract 180 degrees to get that point. Okay, so this is the way how we find the argument and the modulus of the complex number. Once we are done with the argument and the modulus of a complex number, we can easily define the trigonometric form of a complex number. Since this is the Cartesian form of the complex number, now we can easily define the trigonometric form of a complex number. So we suppose that we are given a vector, and here in this vector, this length is A, this length is B. So we have A plus B iota as a complex number. Okay, you know every complex number can be written as, can be represented as a vector, because each real part can be the length of along x-axis, and the imaginary part will be the length of length along y-axis. So we have studied previously, we can always define this this modulus, which is just the square of A plus square of B. Okay, we have studied, and we know that this is called the angle, which is called the argument. The argument is equal to theta, right? If you want to write it as z mod, that means z mod is again the same thing, because z mod here is z mod is a square plus b square. Okay, the square of this plus the square of the imaginary part. Okay, so in this triangle, so I have this triangle. This length is A, this length is B, this length is mod of Z. So in this triangle, we know that what is sine theta? Sine theta is just height over hypotenuse, which is B over the modulus of Z. And similarly, I know cosine theta equals base over hypotenuse, which is A over Z mod, modulus of Z. Okay, so from here I have the Cartesian. What are the Cartesian form of Z? The Cartesian form of Z is A plus B iota. So if I find from here A and B, if I separate from here, A and B can be found in this way. If I multiply this mod of Z with sine theta, I'll get mod of Z times sine theta equals B. Similarly, if I multiply this mod of Z with cosine of theta, I'll get mod of Z times cosine of theta equals A. So I have value of A in terms of modulus and the argument, and similarly I have the value of B in terms of modulus and the argument. So what was my complex number? Since my complex number Z is equal to A plus B iota, if I plug this value of A here and I plug this value of B here in place of B, what will I get? Mod of Z cosine of theta, because A equals mod of Z cosine of theta, plus B equals mod of Z sine of theta, I can take common mod of Z from both of them. I will have cosine theta plus, yeah, here I have iota also because I forgot iota when I was copying, plus iota times sine theta. Okay, and mod of Z here is nothing but this value, square of A plus square of B square root. So I will write square of A plus square of B square root times cosine of theta plus iota sine of theta. This form is called the polar form or the trigonometric form of a complex number.